For a long time, people thought dinosaurs were slow and unintelligent. This perception was largely based on early fossil discoveries and the limited understanding of these ancient creatures. Scientists imagined them as giant reptiles, lumbering around and not doing much thinking. The sheer size of these creatures led many to believe that they were cumbersome and lethargic, unable to move quickly or with any degree of agility. Their brains were thought to be tiny compared to their massive bodies. This assumption was based on the size of the brain cavities found in fossilized skulls, which seemed disproportionately small. This image of dinosaurs dominated popular culture for decades. Early illustrations and scientific depictions reinforced the idea of dinosaurs as slow-moving giants. Movies and books often showed dinosaurs as unthinking monsters. These portrayals were dramatic and entertaining, but they did little to advance the scientific understanding of these creatures. They were simply obstacles for humans to overcome. In many stories, dinosaurs were depicted as mindless beasts that posed a threat to human survival. This view of dinosaurs as dim-witted was accepted for a long time. It was a convenient narrative that fit well with the limited evidence available at the time. However, new discoveries started to challenge this old way of thinking. As paleontologists unearthed more fossils, they began to piece together a more accurate picture of dinosaur life. Scientists began to find more complete dinosaur skeletons. These discoveries provided new insights into the anatomy and potential behaviors of these ancient creatures. These fossils revealed more about dinosaur brains and behavior. The evidence suggested that some dinosaurs had larger and more complex brains than previously thought. Researchers started to suspect that dinosaurs were more complex than previously thought. They began to consider the possibility that dinosaurs exhibited a range of behaviors and adaptations that indicated higher levels of intelligence. The old view of dinosaurs was slowly starting to crumble. As new evidence emerged, the scientific community and the public began to embrace a more nuanced understanding of these fascinating creatures. Paleontologists began to unearth evidence that challenged the old view of dinosaurs. They found fossils of dinosaurs in groups, suggesting social behavior. Some dinosaurs had complex brain structures, more similar to birds than reptiles. These discoveries pointed to a different kind of dinosaur. They weren't just slow, lumbering beasts. Instead, they were active, social animals capable of complex behaviors. This new understanding of dinosaurs was revolutionary. The evidence for dinosaur intelligence comes from various sources. Fossilized footprints can reveal how dinosaurs moved and interacted. Brain cases provide clues about the size and structure of their brains. Even fossilized nests can offer insights into dinosaur parenting behaviors. To understand dinosaur intelligence, scientists use a measurement called the Encephalization Quotient, or EQ. This metric is crucial because it allows researchers to estimate the cognitive abilities of extinct species by comparing their brain size to their body size. By doing so, scientists can make educated guesses about how these ancient creatures might have behaved and interacted with their environment. EQ compares an animal's brain size to its body size. This ratio helps to level the playing field, so to speak, by accounting for the fact that larger animals naturally have larger brains. It's not just the size of the brain that matters, but how large it is relative to the body. A higher EQ suggests greater intelligence. This is because a larger brain relative to body size often indicates more neurons and greater processing power, which can translate to more complex behaviors and problem-solving abilities. When scientists calculated the EQs of dinosaurs, they found a wide range. Some species had very low EQs, suggesting they were not particularly intelligent, while others had surprisingly high EQs. Some dinosaurs, like the Stegosaurus, had very low EQs, even lower than reptiles today. This implies that these dinosaurs likely had simple, instinct-driven behaviors and were not capable of complex thought. However, other dinosaurs had surprisingly high EQs, comparable to some modern birds. Birds are known for their intelligence, with some species capable of using tools and solving puzzles. This means that some dinosaurs, like the Velociraptor, had brains that were large for their body size. Velociraptors, with their high EQs, might have been capable of more sophisticated hunting strategies and social interactions. These dinosaurs were likely capable of more complex thoughts and behaviors than previously imagined. They might have engaged in social behaviors, used tools, or even had some form of communication. The EQ provides a valuable tool for comparing the relative brain power of different species. By understanding the EQ, scientists can piece together the puzzle of dinosaur behavior and intelligence, offering us a glimpse into the minds of these fascinating creatures that once roamed the Earth. Among the smartest dinosaurs were the Velociraptors and the Troodontids. Velociraptors, made famous by the movie Jurassic Park, were small, agile predators. They had large brains for their size and keen senses, making them effective hunters. Troodontids were another group of intelligent dinosaurs. They had the highest EQs of all known dinosaurs, even surpassing some modern birds. Troodontids had large eyes, suggesting good vision, and grasping hands, indicating dexterity. These dinosaurs likely possessed advanced cognitive abilities. They may have been capable of problem-solving, communication, and even some degree of social coordination. Their intelligence was likely a key factor in their success as predators and survivors. Section 5. Living in groups, signs of social dinosaurs. Dinosaurs, the magnificent creatures that roamed the Earth millions of years ago, were not just solitary giants. They exhibited fascinating social behaviors that have intrigued scientists for decades. Many dinosaur species showed evidence of social behavior. These behaviors were not just limited to a few species but were widespread across various types of dinosaurs, indicating a complex social structure. Fossils of some dinosaurs, like the ceratopsian dinosaurs, were found in large herds. These herds were not just random gatherings but organized groups that moved and lived together, suggesting a high level of social interaction. This suggests that they lived and traveled together, much like modern-day herd animals. The comparison to modern herding animals helps us understand the dynamics of these prehistoric groups. Living in groups requires a certain level of intelligence. It involves complex behaviors such as communication, cooperation, and social bonding, which are essential for the survival of the group. Animals need to communicate, cooperate, and recognize each other. These skills are crucial for maintaining group cohesion and ensuring that the group functions effectively. The evidence suggests that some dinosaurs possessed these social skills. They were not just mindless giants, but creatures capable of complex social interactions. This social behavior likely provided advantages, such as increased protection from predators. By living in groups, dinosaurs could better defend themselves and their young from threats. Further evidence for social behavior comes from nesting sites. These sites show that dinosaurs not only lived together but also raised their young in communal settings. Some dinosaurs, like the Maiasaura, built large nesting colonies. These colonies were carefully constructed and maintained, indicating a high level of parental care and social organization. This indicates parental care and possibly complex social structures within the group. The presence of such behaviors suggests that dinosaurs were capable of forming intricate social bonds in communities, much like many animals today. Section 6. Thinking dinosaurs, solving problems and using tools. While it's difficult to prove definitively, some scientists believe that the most intelligent dinosaurs might have been capable of basic problem solving and even tool use. For example, some dinosaurs had grasping hands that could have manipulated objects. While no definitive evidence of tool use in dinosaurs exists, their brain capacity and physical attributes suggest it was within the realm of possibility. Further research and fossil discoveries may yet reveal more about the cognitive limits of these fascinating creatures. Section 7. Evolving brains, from dinosaurs to birds. The evolution of dinosaur intelligence is closely linked to the evolution of birds. Birds are the direct descendants of theropod dinosaurs, the group that includes Velociraptors and Troodontids. As dinosaurs evolved into birds, their brains continued to grow and develop. This evolutionary lineage provides a fascinating glimpse into the development of intelligence. The complex behaviors and cognitive abilities of modern birds likely have their roots in their dinosaur ancestors. The study of bird intelligence can offer valuable insights into the minds of dinosaurs. Section 8. T-Rex, not so dumb after all? Even the mighty Tyrannosaurus Rex, often portrayed as a mindless eating machine, might have been smarter than previously thought. Recent studies suggest that T-Rex had a well-developed sense of smell and good vision. While its EQ was lower than that of Velociraptors or Troodontids, its brain was still relatively large for a reptile. This suggests that T-Rex was not simply a brute, but a capable predator with a complex nervous system. Section 9. A variety of minds. Different dinosaurs, different smarts. It's important to remember that dinosaur intelligence varied greatly. Just like animals today, some dinosaurs were smarter than others. Factors like diet, habitat, and social structure likely played a role in shaping their cognitive abilities. The study of dinosaur intelligence is an ongoing field of research. New discoveries are constantly changing our understanding of these fascinating creatures. As we continue to learn more about dinosaurs, we gain a greater appreciation for the diversity and complexity of life that existed millions of years ago.